Oh, okay. Are you pointed? It looks like
The door is part of our coherence protocol.
Yeah. Is the camera pointed right?
Yeah, that's how it is.
Okay.
All right. You ready for your close up, Mr. Duda? Okay.
All set? Okay, today I'm going to talk about Osprey, the new operating system we're working on at the lab. So, the world is changing.
No, you never sent me your slides, did you?
No. Oh, sorry. Yeah, so the world is changing, and the results might not be that great. And so, when the lab originally came up with Plan 9, the idea was that you were trying to create sort of a time-sharing environment from a bunch of little commodity systems. And it would be really easy to statically administer because you only have a few machines that actually matter. And you can control those pretty easily. And then you use a low bandwidth terminal to access them. And then, but you get a lot more benefits because you have all of your important machines very close together talking over a common file protocol. And since that has a strong security model, it works very nicely too. But the world today really hasn't, it's gotten better, but it really hasn't learned much. Because what you have is the world, instead of doing things like 9P, you're sort of stuck with client-server interaction with HTTP. And that has very sort of poor ad hoc security and a lot of layers of protocol. So you end up with things like REST over WebSockets, thanks Charles, over HTTP, over TCP, over IP. And you really don't have a model for dealing with accessing replicated static content. So you end up with things like Akamai or stuff like that, which add sort of an ad hoc solution. And then dynamic content, you end up with things like AJAX. So you don't end up with sort of a coherent way of solving the world's problem. And that's even worse because the world is changing. And so we're ending up with large static clouds of machines where all the machines and the applications are mobile. And the content, that you're dealing with a lot more content, with movies and stuff like that. And you really want to have it replicated and distributed. And you're also dealing with a lot of mobile applications supported by network services. And so you need to solve a lot of problems to make all this work. You need authentication and access control. And for things like HTTP just doesn't do that because other than basic access in HTTPS, you really don't have a way of adding things or just doing good authentication. And HTTP itself is really not efficient because you're constantly reloading images over streams and stuff like that. And most importantly, the world is now completely mobile. And the way that we do things, by making everything a connection equal to a session, that just doesn't work anymore. Because the minute your connection breaks, you lose your session and all of your state that you were doing before that. And when connections aren't reliable, that just doesn't work. So Plan 9 solves a lot of these problems. You have a well-authenticated RPC protocol. You have namespaces that allow you to bring together a lot of disparate machines. But it doesn't solve all of the problems that we're going to be dealing with soon. So, for instance, how do you add virtualized systems into your NDB? You can kind of get around this by having sort of a pre-allocation of MAC addresses. And then when you add a virtualized system, it'll automatically go into NDB. But that's really a hack, not a solution. And right now you assume that everybody's got a static auth server. So Bell Labs has an auth server, IWP9 has an auth server, IBM has an auth server, Ron has an auth server. But there's no way of saying, okay, if this person can authenticate with me, then I'll let them authenticate with other people too. And the other thing is Plan 9, since it came about in a time when networks weren't as much of a bottleneck as they are now, it sends a lot of file data and stuff back and forth. And really, what you want to do now is you want to do something like MapReduce or something like that, where You move the computation to the data rather than the data to the computation. And also, Plan 9 doesn't do a really good job of saving state. Like, who here has had their drawstring crash? And then had used, exactly. And you have to constantly bring stuff back up, and you can kind of get away with it with your Acme dump or your lib profile, but you end up losing a lot of state every time you log in and you log out. And also, although Charles and Gannon are working on this a lot, Plan 9 really doesn't do well with dynamic replicated data. It expects you to have sort of a centralized file server with all of your good stuff on it. So the question is, how do you solve these problems? And what we're working on in the labs now is a new operating system called Osprey, which tries to solve these things. And so basically what Osprey is it really emphasizes authenticated controlled access to the dynamic replicated data. And that's very sort of buzzwordy, but I'll talk about that more later. And so you want to support cloud invocations, so things like Eric and I are doing, so you want to be able to remotely create programs using file systems. And you want to be able to make sure your stuff, you can checkpoint your stuff, so if it fails, you can start again. And this is very different from the traditional Plan 9 model. You also want to be able to pick up your programs and move them around. So anything you're running isn't confined to the CPU server you're using. And then from an implementation perspective, you want a new operating system that utilizes multi-core better. So you're not constantly locking and doing stuff like Plan 9 does. And finally, what we really, from the ground up, we want to emphasize real-time stuff because we're Alcatel, where we make routers and stuff, and that's really important for us. And finally, we want to make mobility part of the system too. So if you can change your IP addresses on the fly, and the system just keeps on going. So I've said a lot, but I haven't said how we're interested in doing this. So Osprey is a microkernel of library OS. And does everybody here know library OS? Basically, a library OS is one where almost all of your state, like your file descriptor tables, your networking conversations, all of that is actually in user space. So you're not confined by the kernel to do things. And what we're also very interested in doing is creating distributed delegated authorization. So you can have speaks for between auth servers. So if, for example, YouTube, if I can speak for YouTube, then you don't actually have to have a YouTube account. And we've also got a new file protocol called PyP, which is like 9P, but it's more persistent and it's better for streaming. And like I said earlier, we're working on process migration. So when I say microkernel, Osprey is a pretty standard microkernel. It's got fast message passing, it deals with your address spaces for you, it handles interrupts, and it will schedule processes. But other than that, that's pretty much all it does. And message passing is implemented entirely through page flipping if you can. So it's very close to the barrelfish model, if you guys know that. Internally, you've got every process has an address space, and individual processes have segments which are shared between them. And one very important thing is that any group of processes that share segments, they're part of a migration group. So if you want to move one process that shares a segment, the whole group moves. And here I've included a program that's our UART handling. See if I can get the mouse over it. Hey Jeff, is there any way to sort of point? Do we have a pointer or anything that I can go through? I'll hop. Okay, so
Chairs, you can stand on the chairs.
I will.
This is going on YouTube.
Yes. Okay.
Can we go get some private room for no? We can look still. Let's right outside the door.
Yeah. So this is our UART code. This is in the kernel. It's a kernel proc. It will move to user space eventually. But if you look at it right now, it's very different from traditional planning in kernel stuff. So essentially what we do is, the biggest thing to look at here is now we have what's called a select. And a select is just like an alt and regular plan 9, but it's in the kernel. And so what we're doing here is we've got 3 queues and a semaphore, and all of these guys are going to talk. And you'll see what they're doing down here. And so whenever interrupts start, you go basically, you just start a while loop. And what that while loop does is it checks what you should be doing with the getter. And then it selects on your semaphores and your queues. And then it says, based on what you have, did you get a UART, like a control message into your UART? Did you get an interrupt? Or should you send a character to the main queue that you read? And I can actually demo this in action later. But that is essentially how we're doing stuff inside the kernel right now, in terms of microkernel tasks. And now I'm going to talk about our new protocol, PyP. And it's basically like 9P, but the sessions are now completely independent from the connections. So when you start a PyP connection, you say, okay, I want to start this session. It doesn't just create a session with like a T version like it does now. And another important change is that now transactions are pipelined. Anybody that's familiar with Gorka and Gang's POP, it's very similar to that. And another very important thing is that PyP can be done over TCP, but it can also be its own transport protocol. So who here is familiar with CCNX? Well, there's a new protocol that's been very influential to us called CCNX, which is sort of a pull-only protocol that works as its own transport layer. And we're interested in doing similar things. So PyP will live entirely on IP if you need it to. And also very important, PyP also is meant for streaming movies and things like that. So dealing with isochronous data is very important to us for day one. But that said, everything is very similar. Like authentication, exactly the same thing. You have an AFID, you do your authentication transaction on the AFID, and you're good to go. You still have FIDs, QUIDs, and TNI messages. But there are some things that are pretty different. Right now, we actually have what are called string attributes. So metadata has made it into the file protocol. And every file in PyP is now versioned. So it's sort of like Vinti is built into the protocol. And files are, but because you're doing the versioning and stuff like that, files are released, so you can only open a file for a certain period of time before it times out. And when you start a session, the server itself doesn't keep any state. And so it's up to the client to keep track of what it was doing at the time the connection broke. And the server will ask when it doesn't understand anything, like, I don't know this FID. Please tell me what this FID is attached to. And here's a dump. I don't think I'm going to get back up on the chair of a PyP thing. And when I do the demo, I can give you more in-depth into what it's up to. So application-wise, we've got about 5 things that we're really interested in doing here. We're really interested in high-throughput batch jobs, which is another way of saying we're interested in things like MapReduce. And we're Alcatel, so we're really interested in doing routing, gateways, and firewalls. And when we say CloudOS, what we mean is we want a way of being able to dynamically instantiate machines, stuff like EC2. And for thin client stuff, essentially what we want is, if you've got a set-top box or something, you want to be able to turn it on, it reestablishes its PyP sessions, and then it's good to go. And finally, for HPC, the fast message passing and stuff tries to make up for a lot of the problems that Ron and Gang had when they were doing the hack. And so development-wise, Osprey already boots as a real-time scheduler that works. We're in the middle of getting a packet filter for the user space networking, and IP devices already work in the kernel. So, concluding, Plan 9, from Bell Labs' perspective, Plan 9 is the right engineering model for doing things. You want a file system-based way of unifying a distributed system. But the current way that Plan 9 does things just doesn't work for the way the world is changing. And so Osprey gets around this by using a microkernel and migrating processes and caching so that mobility and big, huge distributed systems work better in our model. And so now I'm going to try a demo, and we will see if
It's really big. I think there was some code though.
Just to be silly, what are you running?
what's that?
What environment are you running?
This is 9VX connected to Antwerp, connected to a serial console with an Osprey. And so just to make
Oh, the Skype stop us, everything crashes.
yeah. Well, let's make sure it's actually, I didn't lose my connection because it's not rebooting. Oh, there it goes. Okay, so these are our test kernels we've got right now. And so probably the most interesting ones we have are the UART.
Never run this. Run that one, Noah.
Sure! Can I have a job at IBM? And so, yeah, it wants me to write some stuff on it.
Maybe it's the best version of it.
What? Yeah, this was Osprey.
You have to reboot the kernel after every test, just like
Yes.
stuff.
Yeah. So essentially what the UART test does is it polls to figure out which ones you're connected to, allocates memory, and then what it does is it sends a piping get adder. And so if you read from star on get adder, you'll get all of the possible attributes you have. And these are the attributes for UART. And so what we really want is a baud rate. So we read beat, we get 4 bytes back, 9600. Then we start the UART task, and then I type in some stuff, and then it echoes it, and then the system reboots.
Where's the squid boy?
The squid boy?
It's fake if there's no squid boy.
Yeah, where's the pipe test go? There's the pipe test. Yeah. And this should show you some pipe in action. And I think that actually, is this different from the old one? It used to read the UART. I don't think it's reading the UART anymore. So, yeah, some important things to look at here is that since piping messages are not groups, it doesn't just do a regular sort of convim to S. It has to actually look through, figure out how many messages it has, sort of bring those out. So you can do an open, read, and close all in one transaction. And then you figure out the session here. So if you're restarting an old session, parse the messages. And yeah, here's it completing. Now you're opening. And what is it opening? So yeah, this guy is going through boot. And It's reading something from boot. Oh, yeah, it's reading the directory information from boot right there. And you can see the new root user is Cato instead of Booties. Oh, so, any questions?
So, a question from the net was, you said that files were immutable. Does that mean that files are immutable like Amoeba files are immutable?
Considering it was implemented by Sapamolder, I would say that any sort of things are purely, like anything that's like Amoeba, purely a coincidence.
Yeah.
What is the spec for Python?
Well, as a spec, it was done, it was implemented by a guy named Anant, if you know him, and it was his master's thesis. So his master's thesis is available. PyPy itself changes a lot, so we have a JSON. Basically we have a JSON generator. Yeah.
It spits out.
Yeah.
C.
Yeah, it spits out either C or Go code.
So you write the spec once and it spits out all three.
You need to record Lucho's expression here.
Yeah, here we go. That was worthwhile. Lucho, I want to close up on that expression.
I need something in English, not in C, not in Java.
What, JSON's English?
Yeah.
Play you a not.
Yeah. But no, I have Anant's thesis here. Nobody needs it.
Is it posted online at the Free University or not?
I don't know. It lives in our tree, so that's right there from. Oh, John?
Why did PyPy? That's going to be really hard to type.
I think that it became PyPy because the original.
Because they wanted it to be really hard to type.
It's just a little bit more than a third.
Everyone does that reaction first.
Yeah. Well, one of the original motivating examples for Osprey was a project by Sapa called Peeps, and the idea is to sort of remember. Peeps is a guy who can never forget, and so I think PyPy comes partially from Peeps. Okay.
Could you talk a little bit about the attributes on the files? Is that just some sort of extra metadata?
It is extra metadata, but it's just strings. So essentially, you can read a star and get the names of all the attributes.
And like Mac resource forks?
No, I don't think you. I think it's purely string data.
It's essentially extended.
Yeah.
It's essentially thinking extended ACLs. So stuff that doesn't get copied by CP. It should.
Well, I think that the attributes live in the directory. I don't think they live in the file itself, but I'm not sure because we don't have an in-memory file system yet. I mean an on-disk file system yet. Everything is in-memory. So.
No, there's a question from the network about
Yes.
if any of this is available or is it something that's locked down?
Well, if you give us $5 billion, I guarantee that you can get the source code.
Is there a shell yet?
A shell? Yeah. And
No, there's
but no, we're currently in discussions about an open source license and watch this space.
There isn't a space to watch though because you never gave a URL.
Well, if you give me $5 billion,
Are you pushing these changes in the next
yeah.
The $2 million we've given you guys isn't enough? Or why would you do this?
Yeah. Well, we're in Europe now. France thinks big.
It wasn't in Europe.
Yeah.
Well, just wait. Once Cork is done with the European economy.
Sure.
First is my question.
machine to another, and your process would move. Exactly. Ba-boom.
But that's why you have the session and the protocol. Right?
Yeah.
So, I have an actual serious question.
Yeah.
What do you think about, would it be a ridiculous change to Plan 9 to add sessions to 90?
Well, I would certainly like it. We're working, I think it's done. It happened while I was coming here. But there's a Pipe-E to 9P translator. And because there's already something similar, which is Gorka, you know Gorka's Recover? And I'm sure that Gorka can tell you more about it. Was it Nemo? Was it an Eckert? Russ run?
I'm not sure even if I think Russ got it for someone else and
Yeah. Okay. So Gorka, Russ, somebody else's recovery.
Well, so where's the spec for the extended 90?
The extended 9P?
Well, that's what you need for the session, right?
Well, no. What it does is.
Well, it's more than just the session stuff.
Yeah.
Well, that's what's required for the migration. That's the real magic sauce.
Yeah.
Yeah, I'm less convinced of that. Noah hasn't convinced me of that because the recovery stuff did most of that without a session ID.
yeah, well,
That only works if the file server is not treating SPIDs to the same open file especially, which is perfectly legal. So you can't just reopen the file on the new server and get an equivalent fit.
Why not?
but I didn't
Yeah, client specifies the fit, so why?
Right, but what it connects to is not necessarily the same thing. You really need a session to guarantee that what
You never get that guarantee. You always have to trust the file server to give you the same.
You know what, you really need to do process migration.
Ooh, this should have been a panel session.
Because in the general sense, it never works. You can always find some little thing, they might make the cut for being importable.
I mean, it's going to be quite likely, especially when you're migrating in case of failure, that you're not going to get the same thing even with a session ID.
But clearly you can't migrate. You have virtual machines you can migrate.
Right.
You can migrate with other things too, right? I mean,
Yeah,
you can migrate
there's
with this stuff,
actually,
and as long as everything behaves itself.
There already is a full libc in user space now. In the sense that all of your file descriptors and stuff are there. It's not as useful because it's in Plan 9 right now. So all it does is it has sort of a proxying. So you can pick it up and move it. And it'll try to recreate stuff, but it's not. It will only be really, it'll only show how good it is once it's on top of the screen.
I don't understand why you can't get the same effect with an alternate, with an name.
What's that?
Do you have a timeline?
I don't see why you
Sort of,
put a session on
You
the
need
front of it.
something to fill it.
Well, no. But it's,
You can't necessarily.
but it is. It's progressing very quickly. I mean, it was.
the same file. You pick
or put it this way, you have a timeline for like.
It's actually very easy. There are lots of file servers that do stuff.
Yeah, so Ron's asking if we have a timeline for first user mode boot. And no, I don't think we do, but I think it's reasonable to expect user mode in the next 2 or 3 months.
What do you do on the move on close with migration?
Move on close.
It's a session. It's
I'll have to
No,
look
but
it
it's
up.
but the session stuff is maintained by the client, and so the server won't know necessarily. So if you're migrating the server,
If you're migrating, it works, but what you're saying is just quitting doesn't necessarily.
what is it going to do? I mean, there's a bunch of stateful stuff that I think there's problems that have to be thought through.
Well, but how does the move on close?
What he's saying is that it would, if you have or close, right?
Yeah,
Wait, no, that's actually close. That
but it's,
that doesn't have anything to do with
but
it.
the kernel itself is more of just a message multiplexer. And so,
The file server would see the clone and would remove it. That there'd be no difference there. If
If you migrate between two servers that are sharing, that are transitively mounting another server,
There's no clone, but there's a session, you just reattach to the session on the new.
Well, yeah.
Yeah, there's a lot of details that aren't given in this one.
Jeff? I can't hear you. Can you speak up?
File versioning.
Yes.
Is it, you said that you release a file for a period of time.
Yeah.
And then it will continue to close and then reopen for that period and version itself.
Right. Well, I think the way it works, and I could be wrong because things change quickly, is that you have a lease and the file is only versioned on close. And so if your lease goes out, it just doesn't work. But I'm not positive.
Okay, so, but is it something that as you're editing it, saying, you get an automatic close, you get a new version of that stuff, it's eventually, right, block archive or anything.
I really can't hear you.
Yeah, Charles. No, the question is more, as you're releasing that file,
Yeah.
period of time, you're editing it, some automatic action gives you a new version of it as it closes or extends your lease.
Mm-hmm.
You're effectively still using a block archiver.
Yeah.
Storage.
Yeah, no, I think that's definitely.
Create a new, okay.
Yeah.
How does that differ from, say, the standard file servers? You always get a new version when you rewrite the file. The Quick has a version in it that's always updated.
I don't know.
There's a difference, but I think I'm not able to articulate it.
Yeah.
That would be very interesting.
It has to do with the
Yeah.
semantics of merges between different versions. The update's not the important part. The important part is what happens when you have two people that open at different times so that they have different versions, and they both write to the file, and then they both close. The way that the coherence is managed. And I don't know how to describe what that mechanism is and how it works effectively, but the fact is that Noah can open one at version 32, and I can open, and then someone else can come in and write the file, and I can open it at version 34, and then Noah can write stuff, and I can write stuff, and all three versions somehow get worked out. Now,
Well, you
yeah.
only merge.
I'm not claiming I know what SAPA's plan is for this, and it may just be, the plan may not actually be to merge it, the plan may be to fail when that happens, because someone else has updated out from underneath you. I don't know what SAPA's exact mechanism is, but it's different than the current stuff because there's a link. It's almost like you're dealing with a checked out file, right, from a source control system. And then when you close, you're checking it back in. And if someone else has checked out and checked in while you were checked out and checked in, then something has to happen on the file server, or you have to get an error. And no, you can correct me if I'm wrong. That was my question.
No, I think it's very much like the barista stuff.
So, does the protocol have any concept then of batching a number of changes together from multiple files?
Oh, yeah, about multi-file thing? Yeah, I don't, then there's the grouping stuff, right? I'm not sure how the grouping stuff then interplays with the versioning stuff. It's
Okay. I think I might understand what you're saying, Paul. So what you're asking is,
If a set of related changes to a number of
right,
files.
if you do a whole bunch of changes and then something screws up in the middle, right?
Yeah.
What essentially happens is you send all of your changes, and then it's basically sequentially in the batch that you send, where it breaks, you'll get an R error, and you won't get any more replies back.
Will it also kill my previous changes that are now inconsistent?
Is it a trick? He's asking if it's a
Yeah,
trick.
consistency is a trend.
I don't think it'll squash the changes that are inconsistent, but there will be some event that, and I'm not sure who deals with it. I'm not sure if the client has to deal with it, or the server has to deal with it, or if there's some sort of a collaboration. But SAPA needs to provide more of those details.
Yeah,
And there's white papers that none of us have access to, unfortunately, with those details.
yeah. I think if you
There's
want,
one person in the room that have access to it.
yeah, if you want more information, Paul, I think SAP is very interested in disseminating this. And so if you send SAP a mail and say, I'm interested in getting information about these particular things, then I think he'll be happy to provide it.
Thanks.
So Noah, how are synthetic file servers going to work with PyP?
How are synthetic file servers going to work? I think they're
And the other question is, think of pipes and streams, can one implement these communication patterns in piping? I guess that's right.
Actually, that's a very good question, and that's one of the goals of, yes, you can do pipes and streams, but we're very interested in doing things like multi-pipes that Eric talked about. And so, for instance, because everything is batched, you can put a bunch of records, you can read and write on a record basis without getting the same sort of problems you would in 9P doing a bunch of little reads and writes.
Any other questions from the room or the network? Records? They're about 2 minutes behind, so we're catching up still.
Okay.
Apollo 5, do you have any additional questions? I guess Apollo 5 would have been one of the faraway ones. What would be a good far? 14 years. All right, well, why don't we just, people can mail questions later.
Okay.
Think about it.